With our last problem of this section, the hyperbolic paraboloid, this is the most obscure of the graphs. It might even be the most difficult to draw. It's going to look like a saddle. And in fact, that's why I want you to think of whenever you see this form of y squared over b squared minus x squared all over a squared. That's going to look something like a hyperbola on the left side. Not equal to 1, but equal to z over c. So when you see this, you're going to have a saddle shape. Let's talk about one particular problem, z equals y squared minus x squared, just changing the left and the right sides, and see if we could come about and get a nice way to make a graph. Let's talk traces. I think traces can definitely help you out a lot. Let's maybe consider the xz trace, as well as the yz trace. But we'll do the xz trace first. That means, of course, let y equal 0, the missing variable. So we're looking at this problem here. Let y equal 0. You have z is equal to the opposite of x squared. We would graph this. Looks like it's a two-dimensional graph. Z-axis here, x-axis over here. We would have a parabola opening downwards. Now again, we could begin to graph this out in 3D. We could say, look, we have our x-axis, our z-axis coming this way. That got a little bit crooked. Coming this way, we could say, is our y-axis. But what we're seeing is if we had an xz axis, in other words, erase the y-axis, and you'd say, what would that really look like? Well, we would see something like this. Now I'm going to make this other part dotted down here. You actually could make it solid, but it's going to become hidden from view. We'll see that in a minute. Let's also consider the YZ trace. The YZ trace, of course, what letter's missing? Well, x. X would have to equal 0. So go back to this equation that we have. Z equals y squared minus x squared. Let x equal 0. We would have z equals y squared. Very similar type of a shape, a parabola, once again in 2D. But the big difference is we've got our y-axis versus our z-axis. This time, of course, we would have a parabola opening upwards. Now, what would that look like? Well, again, imagine that the x-axis was erased. You could say, well, I would expect for there to be a parabola opening up this way and a parabola opening up this way. So we probably need a little bit more information. Right now, this isn't really making this look, like I said earlier, that it's going to appear to be a saddle shape. To really help us out, and again, it's just super clear here, we are talking about this graph, z equals y squared minus x squared. Let's just assume that we would look at z equals 1. Z equals 1. Now, if z equals 0, we also have to have x and y equaling 0. The two parabola traces that we drew kind of show that. But look, if z is equal to 1, my goodness, you look at this, you'd say, well, that's a hyperbola. That's a hyperbola that, look, this is positive in the y. You'd expect it to look something roughly like this in an xy plane. Well, now imagine that your z value was, say, a 1 up here. You would expect to see this kind of a hyperbola. You would see something like that. Maybe now a little bit of a saddle shape is taking place. Maybe you can begin to envision that. Well, what else could we talk about? Well, we could say, no, wait a minute, z could be a whole host of different values. It could even be negative. We could Again, up here in green, say what would happen if z was equal to -1? Well, we'd have -1 equals y squared minus x squared. Very tempting, we can say, well, isn't that a hyperbola and y squared's positive? Well, remember at the very first video, we said that our hyperbolas have to be equal to +1. So if I divide both sides by a -1 everywhere, we of course would get a +1 over here. But look, your x squared's now positive, your y squared's negative. Yeah, it's a hyperbola, but it's a hyperbola where you're opening in the x direction now. And again, we'd be one step away. I don't even have to draw everything in super detail. But look, down here would be a z value of -1. You could say, well, I would expect to see, a hyperbola opening this way. And in fact, we can maybe draw that over again, just kind of looking like that. We can say it's also going to be opening, you can see somewhere here. So if we were to really extend this and begin to stretch this out, I think you could begin to believe that we do have a saddle kind of a shape. You can see that certainly here this would continue to drape down. It would drape down over here as well. So you could see the outline of a saddle occurring. The book draws a much nicer picture. Personally, I do think this is the most difficult three-dimensional shape to draw. We're certainly not going to be required to draw something like that in class, but there is something to be said about this shape. Remember, the whole rationale for doing these graphs is to show you what we're going to be investigating with in terms of calculus. We'll be taking derivatives, limits, all that good stuff. Take a look at the origin 0, 0, 0. This is what we would call a minimax point, and it's one of the most famous features of the saddle type of graph. In fact, it's called a saddle point, and our book will even refer to that. Look, on that parabolic trace that the parabola is opening downwards for z equals -x squared, and the very first trace that we drew, that point would be the highest point on that parabola that's opening downwards. Whereas if you look at our other trace, the second trace that we drew, the origin would be the lowest. So that point could be a highest point if you're walking along one direction, one curve. It could also be a lowest point if you're walking along another. We're going to address that later as we talk about what it means to find maxes and mins. But just to let you know, this is the direction that we're headed. We're going to just have a quick lesson the next day and identifying what type of quadric surface we have. We're going to do some completing the square. But even when we take the test, we will have a little guide given to you in regards to the types of quadric surfaces and what they could look like equation-wise. So just wanted to let you know about that. Best of luck to you. We're just going to be reviewing for the rest of the week, taking a test on Friday. So best of luck to you.